Hi, my name's Kaylin and I'm a senior here at the University of Florida. When I first entered UF, I wasn't really sure what I wanted to study long term. I knew that I wanted to earn my PhD, but I wasn't sure in what. My very first semester I took an entomology class and I absolutely fell in love with the unit on social insects. Soon after that, I changed my major to entomology and began volunteering and working in various labs. One of those labs I've spent a good chunk of my time in is the honeybee lab. I now know that I want to go to graduate school to study honeybees. I'm very interested in their pests as well as management strategies that beekeepers can employ against them. And that's where the knowledge from this class comes in. I've really enjoyed learning about how to evaluate the risk that a pest poses to a specific region. I know I can use this knowledge to evaluate the risks of the pest to honeybees. Now, most people who are familiar with honeybees, even just a little bit, have heard of Varroa. This is currently a mite that is the top pest to the honeybee, Apis mellifera. One mite that is not as well known that poses a high risk to bees here in the United States is a mite known from the genus Tropilelaps. This mite poses a high risk to beekeepers in the U.S. based on its fast reproduction, difficult detection, its virus transmission, and its similarity to the known Varroa. Now, Tropilelaps is a genus that contains 4 species, 2 of which are known to feed on Apis mellifera. Tropilelap mites feed on the hemolymph, unlike Varroa, which feed on the fat bodies of immature bees. Due to the inability to feed on adult bees, these mites spend a majority of their time down into the brood cells. Tropilelap mites originate from Southeast Asia, and there they survive in the hives of another species of honeybee, Apis dorsata. Apis dorsata are much larger and have a little bit different life history than Apis mellifera. The first component that make these Tropilelap mites have a high risk to bees is their fast reproduction. The total life cycle of a Tropilelaps mite includes an egg, 3 nymphal stages, as well as, of course, adulthood. It takes 12 hours for one egg to hatch, and then only 5 to 6 days for that nymph to become an adult and ready to reproduce. This very short life cycle means that Tropilelaps can quickly take over a honeybee colony. The second factor that contributes to the high risk that Tropilelap mites pose to beekeepers in the United States is its difficulty of detection. As I mentioned before, due to their life history, a majority of mites at one time are down into the cells of a colony. This makes it difficult for a beekeeper to hold up a frame and see any mites, not to mention that they are half the size of a varroa mite, which is already very, very small. A third factor that contributes to the risk that Tropilelaps might pose is the transmission of harmful viruses. These viruses can lead to malformed or diseased adults with shortened lifespans, and they also create an opportunity for the entry of secondary pests. Secondary pests come into already weakened colonies and can drive them into the ground. Examples of some of these secondary pests are small hive beetles and wax moths. In very extreme circumstances, Tropilelap mite infestations can be so high that it causes all the bees in a hive to completely leave, including leaving the brood and food resources behind. Finally, what is so concerning about the Tropilelap mite is that it is already known when coexisting with Varroa to outcompete it due to its destructive nature and high reproductive rate. Considering the destruction that Varroa has already caused to hives and beekeepers financially in the United States, we should be very concerned about not allowing Tropilelaps to enter the U.S. Prevention is the best phytosanitary measure we can take here because treatment and even detection is so difficult. One necessary practice that needs to be implemented is ensuring that no full hives, are coming into the U.S. from areas where tropicolaps are known to exist. Instead, if bees need to be transported from these regions, they should be transported in what we like to call as beekeepers packages. Packages are a plastic or wooden box with ventilation allowing the bees to not overheat, but it only includes adult bees and a caged queen. Considering the biology of tropicolaps and with majority of the mites existing down in brood cells, the transportation method of packages eliminates all of the mites that would be down in the brood cells, and because these mites cannot feed on adult bees, all remaining mites on the bodies of the bees should die before they enter their final destination in the United States. If a hive is suspected to contain tropicolaps, there are a variety of methods used to monitor and detect these mites. These include sugar shakes, alcohol washes, and finally, the bump method. A sugar shake consists of taking a sample of 300 bees in a jar, adding 1 to 2 teaspoons of powdered sugar, allowing the bees to coat themselves, and then shaking the jar over a wet paper towel or white container filled with water. This allows us to count the number of mites that have fallen and calculate the number of mites per bee for that hive. An alcohol wash contains very similar methodology, except replaces the powdered sugar with an alcohol such as ethanol. Although this kills the bees and they cannot be put back into their hive, it does provide a more accurate measurement. The bump method consists of removing a frame of brood cells, brushing all of the adult bees off, and bumping the sides of each frame twice over a damp paper towel or white surface. All three methods allows us to count the number of mites in a given sample, so we hopefully can detect if those small but incredibly dangerous mites are present. Overall, tropicolaps will directly impact my future career by threatening the species I desire to study. In addition, tropicolaps will influence my thought process as a professor, as a researcher, and as a beekeeper myself. As a researcher, I will need to design specific studies to evaluate the detection and treatment methods of tropicolaps if it is to enter and become a problem in the United States. As a professor, I will need to concisely communicate about this pest to my students. And finally, as a beekeeper, I will need to implement the proper practices to ensure that my own colonies are not harmed due to this dangerous mite.